Welcome to this Tutoring Center video. You can follow us on social media if you'd like. I will be presenting today. For today's presentation, we are going to try to get an intuitive understanding of Bode plots. Let's learn about Bode plots by analyzing this circuit. This circuit is a low-pass filter, and we are going to first find an expression for its gain, because that is what we plot when we do Bode plots. A Bode plot is a plot of the magnitude of the gain as a function of the frequency. We can quickly find the expression for the gain by recognizing that the circuit is just a voltage divider. We'll use the voltage divider formula and then multiply the top and bottom by j omega c to put it in a neater form. Recall that the time constant, tau, is R Thevenin times the capacitance, which in this case is just RC. The break frequency, which I will call omega naught, is 1 over tau, or 1 over RC. Let's plug in omega naught into our gain equation. Also, let's write it as T of j omega, where T stands for transfer function. We are not changing anything about the function, just representing it in a more standard way. Finally, let's replace j omega with an S, because that is also typical. Now let's take the magnitude of our transfer function. As previously stated, a Bode plot is a plot of the magnitude of the gain as a function of the frequency. You take the magnitude of the top and bottom. In this case, the top stays the same. For the bottom, remember that S is j omega, so the S term will be your vertical term or your imaginary term. If this step is unfamiliar to you, then I recommend reviewing how to find the magnitude of phasors. Once we have the magnitude, we want to convert it to decibels. Sometimes students are puzzled by what a decibel is and why we use it. A decibel is just a unit of measuring gain. It was invented for convenience, just like any other unit, like the meter or the gram. Some students also ask, if we are converting to decibels, what unit were we converting from? Gain is typically unitless, like in this example. Our gain is V out over Vin, which would be volts per volts, which cancels out, making it unitless. So we are taking a unitless gain and converting it into decibels. To convert to decibels, take 20 times the log of the magnitude of the gain. Remember an important property of logarithms. Log of a over b equals log of a minus log of b. Let's use that property to simplify our expression. Also, remember that log of 1 equals 0, because 10 to the 0 equals 1. Now that we have our simplified expression, we are ready to start thinking about what the Bode plot should look like. When the frequency is much less than the break frequency, the S over omega naught will be a small number, close to 0. Try plugging in a very small number for S over omega naught into the transfer function from the previous slide and see what you get. You should get something close to 0. So we have unity gain, or 0 decibels, before the break frequency. When S equals the break frequency, S over omega naught equals 1. So our transfer function will be negative 20 log of square root of 2, which is about negative 3 decibels. And when S is much bigger than omega naught, our transfer function will approximate to negative 20 log of s over omega naught, because the plus 1 under the square root sign will become obsolete. It is important to understand that after the break frequency, the gain will decrease by 20 decibels per decade. You can test this out by plugging in s values, such as s equals 10 times omega naught, s equals 100 times omega naught, and s equals 1000 times omega naught. You can see here that the gain does indeed decrease by 20 decibels per decade. Now we can draw the Bode plot. The dashed blue line is what you would draw for your Bode plot. It is an approximation. Before the break frequency, we can see that the gain is at unity, 0 decibels. After the break frequency, the gain decreases at 20 decibels per decade. The red line is meant to be what the actual Bode plot would look like, which you could do on a computer. Hopefully, this exercise has given you a more intuitive understanding of Bode plots, what they are, and why we do them.